Today's video we're going to be taking a look at question 17 from the QCAA External Exam Specialist, and we'll be looking at question 17 from, I believe it's paper 1 from 2020. Now, like all the videos on the channel recently, you would have noticed I've started splitting up all the questions into individual videos. That way, if you only struggle with a certain type of question, you can go watch that on the channel. In saying that though, the full exam is still up on YouTube. The link is in the description below. If you guys need a specialist external exam bundle pack, the link is also in the description below, so you can go check that out. But otherwise, yeah, if you have any questions, leave it in the comments and try and timestamp when you have your question, and I'll try my best to answer it. Okay, so question 17 here, all they're asking is determine the smallest positive value of A given this, and this is tech free. Okay, so first of all, everyone's going to think, how do we integrate this? What I'm going to think is, how do we change how this looks? Because I don't think anyone is going to integrate that straight away. Okay? What we want to do is look at what we've been given here. Specifically the trig here. Okay? We've been given a bunch of trig identities that aren't really common. You've been given tan, sec, and cosec. Okay? Now, when I say common, I mean it's not like your typical sine, cos, etc. However, there's one characteristic here that I want you to notice when you're doing this question. Notice that all of these are exactly the same, okay? Which means if we can make them in terms of other things that are similar, we can start cancelling and merging things together. So first of all, we've got to understand what we're looking at here. So sec is actually 1 over cos. So we can think of that as 1 over cos of 2x. We also know that cosec is 1 over sine. And then for tan, we know that tan is actually just sine over cos. So here, why is that important for us in this question here? Well, it gets everything in terms of the same thing. Rather than having 3 different things, we have 3 things all in terms of sine and cos. Now, chucking that in may be a bit difficult if you struggle a lot with fractions. However, this is the only way around this question, okay? So here, I would say if you're going to try and get 7 out of 7 on this question here, you should be comfortable with these fractions bits here, okay? So what we're going to do is substitute each of these fellas in. So here we'll have 1 over cos 2x plus sine 2x over cos 2x divided by 1 over, what was it? Just checking our substitute in. Yep, that's going to be the sine. Now, you might be wondering how you think to even do this in a question like this. Well, you've got to ask yourself, if you're not going to change the trig, the alternative is to integrate that straight away, which isn't great. And I don't think anyone in specialist could, unless you got taught other techniques. So changing the trig is the best way around this, okay? Now that we've got something like this here, what we can start to notice is there are some similar things here, okay? Now, hopefully you can see that these guys actually have a common denominator, which is good. So you can merge those top fractions together. However, on the bottom, we can't necessarily merge these two together straight away because they don't have a common denominator. But that doesn't mean we can't make them have a common denominator. Because remember, if you have the number 1, you can change the number 1 into anything you'd like, as long as you're dividing by itself. So for example, 1 could be 1,000 over 1,000. 1, in this case here, we are going to transform into sine over sine. Now, just sine of 2x in this case here. Because I'll be able to merge those things together then, okay? So why don't we just do that? Now, I'm going to make this a lot smaller because I'm going to run out of room when writing this stuff here. This is all this trig here, by the way, as well. So here, the top of the fraction will be 1 plus sine 2x all over cos 2x. And if you're wondering where I've gotten that from, that's that common denominator in the blue just there, okay? Divided by, in this case here, it'll be 1 over sine 2x plus sine 2x over sine 2x. Now we're going to do the exact same thing we did on the top and merge those fractions together because you can see they have a common denominator of sine 2x. So what I'm going to do is rub that out, If I make one mistake, I'm going to restart this whole video, but it should be fine. Let's go here. So we've still got this bit here. Now, what I want you to notice about this is obviously we have a bunch of fraction stuff occurring here, but I want you to notice something that they have in common. And hopefully you can see it, just like I can see it here. So here we've got this ugly looking mess here. Hopefully you can see that and that are the same thing. Now, if you're not comfortable with evaluating that fraction, that's okay. You could factor out the 1 plus sine of 2x. But let's understand what this fraction is actually saying. Now, I think one of the big things that gets everyone in all math is fractions and negatives. It doesn't matter how smart you are. The only reason you really get lost stuff wrong is because of little things like that, if you understand the concepts clearly. So what this means here is it means this divided by this, which means if you go, let's say 5 divided by 8, that's the same as 5 times by 1 over 8. So why don't we just do that here instead of doing another division? Let's turn it into a times. So it's going to be this bit here. Let's just copy that. Oh dear. This is why I'm never... No, I'm just going to write it out. So we have this thing here divided by this. So we're going to write it as times by this flipped upside down. So times by sine 2x over 1 plus sine 2x. Now hopefully you can see those two cancel out. So all we're left with is sine 2x over cos 2x. Now sine over cos is tan. So that just turns into tan 2x. So that complete thing there in the green just turns into tan of 2x, which is crazy. Anyway, enough said there about the trig. Now we can actually start the integration because, again, we're not finished the problem. This is probably I'd say this is the hard part about the problem, but the next bit's still pretty tricky. But if you can get to this bit here, you should be able to work out the final bit here. It's like a lot easier in comparison. Likewise, if you have any questions what I just did there, leave something in the comments, okay? So this integral turns into the integral of negative a 1 plus tan squared 2x dx. Now what we've got to ask ourselves is what can we integrate in specialist? Well, if we're thinking about tan, I don't think we actually have the integral for tan at all. I think we have the derivative for tan and we have the derivative of the inverses, but we don't have one for tan necessarily. What we do have access to is this here. So you should be able to see a picture I've just put on the Word doc here. You get access to this. Now, why I think doing this is important is because it gives you access to something you already have access to in the specialist syllabus. You can integrate sec squared, which means in this situation here you can transform that crazy integral into sec squared, which means you can then evaluate because it will turn into tan of x. I'm just moving the screenshots onto here because I don't know how to record multiple screens yet, but that's okay. Okay, now the reason why I'm saying we should use this is because this is literally textbook that there. So we can replace it with sec squared of 2x. So let's just do that. So the integral negative a of a sec squared 2x dx. Now what we've got to understand is when we integrate the sec squared, while it will turn to tan x, we have to divide by the derivative of the inside function. So the derivative of the inside function is 2. So therefore you have to divide by 2. So this turns into 1 over 2 tan 2x negative a and a. And they said this is equal to 1. Okay, cool. Let's get rid of that now. Hopefully you can see what I've just done there. Okay, let's go here. Now remember, this is tech free, completely tech free as well. We need to work out the smallest positive value of a with this here. So here, just treat it like any other integral. Start chucking the bounds. So it's going to be a half tan of 2a minus a half tan 2 times by negative a equals 1. Now, what we've got to establish here is something quite important. How do I work out negative of a tan? Well, think of it like this, okay? So, tan is what we call a odd function. So, if something's an odd function, so if you have f of negative x, that is the same as negative f of x. The reason why it's odd is because it follows this property here, okay? Now, in this situation, if we think of the tan curve looks like this. And yes, it does have asymptotes along here. However, if I chuck in, let's say that's positive a, I'm going to get f of a. If I chuck in negative a, I'm going to get the negative version of that guy there. So I'm going to use this property to change this guy into negative tan of 2a. Hopefully you can see why I've done that. Now the reason why I've done that is to have a half tan 2a. Now because it's already got a minus in front of it, because we're basically bringing the negative out the front, that's going to turn into a positive. Now I've got something like this, where I've got quote-unquote like terms there, okay? I would say that's the next hardest bit about this question. Most people don't get past that there, okay? Okay, let's move this stuff out the way. Let's move this up. Now, hopefully you can see, if I've got half of tan of 2a, and I've got another half of tan of 2a, I just have tan of 2a equaling 1. Now, in this situation here, we've got to ask ourselves, okay, if I were to move tan to the other side, I would have to tan inverse both sides. So I've got 2a equals tan inverse of 1. Tan inverse of 1, we've got to think about that. Tan is opposite over adjacent. Now, if it's 1, that means the sides are exactly the same. It is like a 1 to 1 there, which means the angle has to be 45 degrees, roughly, okay? Or pi over 4. Now, I'm going to write in terms of radians in this case here because we've got numbers present here instead, okay? So here I'm going to say tan inverse of 1 is pi over 4. Now, what you may be asking as well is why aren't we using the other ones as well? Because there's that solution, that's where pi over 4 is, but there's also here. Look at the wording, the smallest positive value of a. This is still going to be positive, so I only need to care about one of them here, okay? So here I can now go tan inverse of 1 is pi over 4. So I have 2a equals pi over 4. Divide both sides by 2, so a equals pi over 8. So the smallest value of a that makes this possible is pi over 8. That is a hard question to do, okay? Now you might be wondering, oh, that only took you 10 minutes, etc. I've taught this question to so many kids, it's not funny. So, of course I'm going to know how to solve it and know how to explain it. Realistically, it would take probably 20 minutes, this question, when you're doing it fresh, okay? Now, hopefully, what makes this question easy is the fact that these are all the same here. If it wasn't, that would be a lot more difficult, okay? Now, if you have any questions at all on this question, leave something in the comments. If you guys want a specialist external exam bundle pack, the link is in the description below. But otherwise, I'll see you guys in the next video.